Dear brothers and sisters, our channel mission Viksit India discusses new and innovative ideas in every video to help make India a fully developed nation by 2047. As the Union Cabinet has approved the Viksit Bharat Shiksha Adhikshan Bill 2025, which will soon be introduced in Parliament to reshape India's higher education governance, today we are making a respectful public appeal to all members of Parliament. At this critical moment, when a single national framework for higher education is being created, India must ensure that frontier technologies, long-term research and development funding, and scientific leadership are embedded at the heart of the law, beyond politics, beyond party lines, and in the national interest. Dear brothers and sisters, stay with us till the end of the video, and do share your thoughts in the comments. Dear honorable members of Parliament, this video is not for or against any political party. This is not about elections, this is not about ideology, this is about India's future. In 1947, India earned political freedom and sovereignty. By 2047, India must earn scientific and technological sovereignty. If we fail to act today, future generations will ask, when the world was rewriting the laws of science and power, what did our parliament do? So, where has the world reached today? The world is no longer just competing on roads, buildings, or factories. The real race today is all about quantum technologies, photonics and light-based computing, artificial intelligence for scientific discovery, gravity engineering and space habitation systems, and, of course, synthetic biology and climate engineering. The United States, China, and Europe have already declared frontier technologies as their national strategic objectives and assets. India definitely has talent. India has ambition. But does India yet have a strong legal and funding framework to lead this race? What is India's real bottleneck? Honorable members of Parliament, India's problem isn't a lack of intelligence. The real issue is the absence of a dedicated frontier technology curriculum law, long-term mission-based research and development funding, modern test beds, and national laboratories and legal protection for scientists and researchers. We're producing degrees but not deep technological capability. So, what exactly is frontier technology, and why does it matter so much? Frontier technologies are those that actually reshape civilization itself. We're talking about things like quantum systems, photonics and light engineering, gravity and space systems engineering, quantum biology, bio-AI and synthetic life, and even climate and clean energy engineering to create, for example, an oxygen emission engine. These technologies would not just create jobs, but they would create entirely new industries, new power balances, and even new futures. If India does not lead in this space, then India will simply remain a consumer of other nations' inventions. How have other nations built frontier tech leadership, and why must India act now? Honorable members of Parliament, frontier technology leadership is not an accident. It's actually the result of decades of early investment, legal clarity, and a really sustained national focus. So, let's take a quick look at how the United States built its lead in frontier technologies. Back in 1945, Vannevar Bush's report, Science, the Endless Frontier, really set the stage for U.S. science policy. Then, in 1958, NASA and DARPA were established in response to the Sputnik shock from USSR. Through the 1970s and 80s, semiconductors, the internet, and space systems all matured. In the 1990s, quantum information science started receiving formal funding. Fast forward to 2018, and the National Quantum Initiative Act was passed. As a result, the U.S. now dominates quantum research, AI, space systems, photonics, and advanced materials. Now, let's talk about Europe. In 1954, CERN was established to focus on fundamental physics. During the 1990s, the EU framework programs kicked off supporting long-term research and development. Then, in 2013, the €1 billion quantum flagship program was launched. Because of these efforts, Europe leads in precision science, photonics, climate engineering, and materials research. And finally, here's how China has been catching up and even competing with the West. In 1986, the 863 program was launched to push high technology. By 1997, the National Basic Research 973 program was underway. In the 2000s, the country poured massive state funding into frontier science and technology. In 2016, China launched its first quantum satellite, Michus. Then, in 2021, the 14th Five-Year Plan declared quantum, AI, and space as strategic technologies. So, as a result, China now competes with the US in quantum communication, space infrastructure, photonics, and AI hardware, and is actually expected to surpass all Western nations in frontier technologies by or before 2050. So, let's take a quick look at Japan's journey in frontier technology. Back in the 1950s and 60s, they focused on post-war science reconstruction. By the 1970s, Japan was really dominating in photonics and semiconductors. Moving into the 1990s and beyond, they made huge strides in robotics, advanced materials, and precision manufacturing. As a result, Japan transformed itself into a technology exporter, rather than a technology buyer. Now, let's talk about India, and the hard truth. India's systematic frontier tech policy initiative. Honestly, it's been mostly after 2015. The quantum mission was only announced in 2023. Funding is still quite fragmented, and there isn't any dedicated frontier tech law. We don't have protected 15 to 20-year R&D missions, and curriculum adoption is still optional and slow. Here's the alarming truth. India entered the frontier tech race 70 to 80 years later than others like the USA, Europe, China, and Japan, and this gap isn't just academic, it actually means we end up depending on foreign technology, facing strategic vulnerabilities, and missing out on trillion-dollar industries. Why this is alarming? Honorable members of Parliament, every nation that leads in frontier technology today started decades earlier. Leadership is built on early curriculum, patient funding, legal protection for science, and political agreement. If India wishes to lead, not follow, this decade is the final window. Delay now means permanent dependence later. Public message to Parliament. This is not a criticism of any government, this is a warning from history. If Parliament acts now, India can still lead in selected frontier domains. If Parliament delays, India will remain a buyer of other nations' breakthroughs. The choice before Parliament is historic. Honorable members of Parliament, so far, we have seen that in many frontier technologies, several countries began decades earlier than India. However, that is not the full picture. There are specific frontier technologies where no country has yet established decisive global leadership. These areas are still scientifically open, strategically undefined, and institutionally underdeveloped. This is where India still has a historic opportunity. If India acts now, with precision, long-term commitment, and legal clarity, leadership in these areas is not only possible, it is achievable. Gravity engineering and advanced gravitational systems. So, here's the global status today. Gravity is studied mainly as theoretical physics. No country treats gravity as an engineering discipline. Research on gravitomagnetism, frame dragging, and artificial gravity, well, it remains fragmented. So, why is gravity engineering still an open field? Well, there's no national curriculum on this topic anywhere in the world. There aren't any long-term mission programs focused on it, and there are no dedicated engineering frameworks either. Now China has actually made some progress. They've managed to manipulate gravity and have built a land-based simulated lunar surface zone. In this zone, astronauts experience about 1/6 gravity, which is pretty much what they'd feel on the moon. And just to be clear, this isn't virtual reality. They use magnetic levitation, vacuum chambers, and balancing systems to partially neutralize Earth's gravity. While this isn't true gravity control, it definitely points us in the right direction. Chinese scientists have, you could say, taken the first practical step toward gravity manipulation. This is honestly India's brilliant opportunity. To take the lead, India must establish the world's first gravity engineering curriculum. It should be linked to space habitats, deep space propulsion, and energy systems. And India can define the engineering language of gravity for the 21st century. After graduating, our gravity engineers would be doing remarkable jobs such as, first, designing zero-fuel, gravity-assisted spacecraft; second, building lunar bases with artificial gravity sections; third, developing gravity gradient navigation system as a GPS alternative in deep space; fourth, creating sky-suspended megastructures and air-anchored sky bridges; fifth, setting up airborne logistics hubs and floating solar farms. Next up, photon structuring and receptive ray engineering. The global status today is that there's a real chance to establish the world's first photon structuring and receptive ray engineering curriculum in India. Right now, photonics is mostly used for communication and chips. Light isn't really treated as a structured physical field for sensing, scanning, or energy control, at least, not yet. So, why is photon structuring still an open field? Existing work mostly focuses on individual components, not on complete systems, and no nation has yet launched a receptive ray or a deep space light field mission. This is really India's opportunity, and to make the most of it, India must develop structured photon systems for things like deep space observation, non-invasive sensing, as well as energy transmission and scanning. By doing this, India can actually lead a brand new area that goes beyond just conventional photonics. Third, let's talk about biophoton imaging and cell-level light diagnostics. The global status today is that first, we need to establish the world's first biophoton imaging and cell-level light diagnostics technology curriculum in India. Right now, medical diagnostics mainly rely on chemistry and radiation, but the biophoton emission from living cells is still underexplored. So, why is this area still open, you might wonder? Research does exist, but not really at a national mission scale, and no healthcare system has actually adopted biophotonics as a core diagnostic platform yet. This, right here, is India's big opportunity. For this, India must pioneer non-invasive early-stage disease detection, integrate physics, biology, and AI, and also build affordable diagnostics for global healthcare markets. Now, let's talk about artificial photosynthesis and oxygen-positive energy systems. Globally, here's where things stand today. We could establish the world's first artificial photosynthesis and oxygen-positive energy systems engineering curriculum in India. Right now, most countries are mainly focusing on carbon capture, and energy systems are still, by and large, extractive or just compensatory. Why is this still an open field? Artificial photosynthesis is still experimental. There's a lot of work to be done before it becomes mainstream. No country has deployed it as a national energy strategy. This is really India's opportunity, and here's what India must do. India needs to lead in developing oxygen-emitting fuels and carbon-negative energy. It's time to move from just climate compliance to actual climate leadership. And since synthetic chlorophyll has already been invented by Professor Max Crossley of Sydney University, it's necessary for us to create entirely new clean energy industries and clean energy engines and vehicles, like, for example, an oxygen emission engine and vehicle. Let's talk about conscious cities and bio-AI governance systems. The global status today is that we still need to establish the world's first conscious cities and bio-AI governance systems engineering. Right now, most smart cities rely on sensors and data dashboards, and AI governance is mostly focused on automation, not awareness. So, why is this area still open? It is because we don't yet have an integrated model that really links human behavior, environmental signals, and adaptive urban systems together. This is indeed India's opportunity. For this, India must build cities that respond intelligently to people and ecosystems, pioneer bio-AI governance frameworks, and set global standards for humane, adaptive urban design. Why is this window truly unique? Honorable members of parliament, in these areas, there is no established global leader, no dominant curriculum, and no monopolized intellectual ecosystem. This moment really resembles space science in the 1950s and quantum technology in the early 2000s. If India creates enabling laws now, launches long-term national missions, and embeds these areas into education and research and development, then India will not merely catch up. India will define the direction of these frontier technologies. This is a direct public message to Parliament. Leadership in frontier technology does not always mean winning existing races. Sometimes leadership actually means creating a new race. India still has that opportunity, but this opportunity will not wait. This is Parliament's historic responsibility. Parliament's greatest role is not governance alone, it is future-making. Today, Parliament has an opportunity to rise above politics and deliver something truly historic. A legal framework that secures India's leadership in frontier science and technology for the next 50 years. This must not be a government law, this must be India's law. What should India's frontier technology law really contain? We respectfully urge Parliament to ensure, first, a frontier technology curriculum mandate. That means quantum, photonics, gravity, space, and bio-AI in our universities, regular syllabus renewal, and a strong push for interdisciplinary education. And next up is the National Frontier R&D Mission Fund. We're talking about an initial allocation of somewhere between 25,000 to 50,000 crore rupees. The idea is to have protected funding cycles that last 10 to 15 years. This is all about mission-based investment, not just short-term grants. Now, let's discuss researcher protection and freedom. Scientists should have long-term security in their work. Failure needs to be seen as a way to learning, not as misconduct. And of course, we need to make sure researchers are protected from any kind of political interference and physical harm. Finally, there's the national testbed and lab infrastructure. We need to establish cutting-edge labs in every region so that students actually get access to real systems. This is super important for hands-on learning and innovation. So, this is a non-partisan public appeal. This appeal is made to members of the ruling party, members of the opposition, and regional and national representatives alike, because science has no party, but its consequences shape every government. The decisions taken today will define India's global standing in 2035, 2047, and beyond. Honorable members of Parliament, history will not ask how many speeches were made in Parliament. History will ask, did Parliament prepare India for the future? This is the moment to rise above politics. This is the moment to stand for science. This is the moment to build India's frontier technology leadership. Nations that lead in science do not do so by chance. They do so by law, by courage, and by long-term vision. History remembers not those who followed existing paths, but those who had the courage to chart new ones. The Mission Viksit India channel is dedicated to giving India's research and development ecosystem a new direction, renewed momentum, and the courage to pursue bold scientific frontiers. Do you believe that a truly developed India will be one where frontier science and technologies form the central pillar of Viksit Bharat rather than remaining with peripheral ambitions? Today, when information technology opportunities are in decline, India must chalk out a new path of frontier technologies to leap ahead in the world for creating very large job opportunities for Indian youth and foreign youth alike. We invite you to share your views in the comments, forward this video to your Member of Parliament and Member of Legislative Assembly, and participate in this national conversation. Subscribe for more content focused on future science, innovation, and India's long-term technological leadership. Thank you for watching till the end. Jai Hind.